Welcome students to the next lecture. So in the previous video lecture we stopped at the functions of the MAC layer. Okay, so MAC layer has two functions. One is the reliable data recovery. Actually three functions. One is the reliable data delivery. Then you have the access control, and the third function is your security. So in case of your reliable data delivery, uh, you know it is more efficient to deal with the errors at the MAC level than, let's say, the higher layers such as TCP. So the reason behind this is that the timers that are used for retransmission at higher layers, uh, such as the TCP, are typically on the order of seconds. So if you make more errors at the higher layer, then your delay is more, because the retransmission associated with the errors in the higher layer have higher order timers in the order of seconds. But in case of the MAC layer, of less time order, so it is always more efficient to deal with as many errors as possible in the MAC level itself. Okay, so therefore this reliable data delivery is one of the functions of the MAC layer. So within that you have the frame exchange protocol. So the source station transmits data and the destination responds with an acknowledgement, and if source doesn't receive the acknowledgement, then it retransmits the frame. And within this frame exchange protocol, you have four types of frame exchanges. So one is the RTS. So the source issues a request to send frame exchange. Then the destination responds to this with a CTS or clear to send, and then the source transmits data, and then the destination responds with an ACK. So coming to the other function of the MAC layer, and which is basically the most important function, is the access control. So the IEEE 802.11 working group considered two types of proposals for a MAC algorithm. One is the distributed access protocols, which, like the Ethernet, distribute the decision to transmit over all the nodes using a carrier sense mechanism. Okay, and the next one is the centralized access protocols, which involve the regulation of transmission by a centralized decision maker. So a distributed access protocol makes sense for an ad hoc type of network where peer workstations are there, and may also be attractive in other wireless LAN configurations that consist primarily of bursty traffic. Okay, whereas a centralized access protocol is natural for configurations in which a number of wireless stations are interconnected with each other, and some sort of base station that attaches to a backbone wired LAN. And it is especially useful if some of the data is time sensitive or high priority. So you can have two types of mechanisms, and within that you have two types of functions, DCF and PCF. So DCF is decentralized and PCF is centralized, and both are available to the LLC layer. So this is the architecture as it stands. So you see, in the MAC layer you have the PCF and the DCF. Okay, so the DCF is applicable to all these types of um, standards. So 802.11a, 802.11b, 802.11g, and so on. So this is basically a more common form, and then the PCF, or the point coordination function, is mainly applicable to 802.11a, b, and g. So this is a contention free service, and this DCF is contention services. Okay, so so in a MAC algorithm for 802.11, it provides basically a distributed access control mechanism with an optional centralized control built on top of that. So the point coordination function is basically, it's a centralized MAC algorithm used to provide contention free services, and the DCF is for contention services. So let's see the details of those. Let's first focus on the DCF. Okay, so this is decentralized, as the name suggests, and within this there is a specific protocol called CSMA, which is carrier sense multiple access. So basically, distributed coordination function, as you saw in the previous slide, is a contention service. Okay, so to account for contentions, okay, um, you have this CSMA protocol. So contention is basically when two or more senders are trying to access the medium at the same time. So there is a conflict. Okay, when two or more senders are trying to access the medium at the same time, there is a conflict or contention. Okay, so when that happens, the CSMA takes care of such situations. So basically, CSMA allows all the transmitters to listen to the medium. Okay, so if the medium is idle, then only you transmit. Okay, but if the medium is not idle, if it is busy, then the idea is to wait for a random time. Okay, and then transmit. If the medium is found busy again, then you expand the mean waiting time, randomly wait, and then try again. Okay, and each time you are waiting, you increase the waiting time by a factor of 2. Okay, and this is what happens in the binary exponential backoff algorithm. Okay, so I'm not going into the details of this algorithm. If you are interested, I encourage you to look up in the internet and find out what is this for, and do some self-study on your own for this. So this process basically responds to heavy loads, and since the nodes do not know the loads of other nodes trying to send, this random weighting each time by factor of 2 works very well. Okay, so I will move on, and if you are interested, then you can see the book of stallings that I suggested. So chapters 13 and 14 of the book, okay, are associated with all these details. Okay, so you can go and look into the book about these details. Anything that I'm discussing in this lecture can be found in chapter 13 and 14, and I would encourage you to go and look into the book for more details that these slides don't provide. So for this particular topic, WLAN, I think it would be better if you go and look up into the book. So let's move on with this concept of interference space. So to ensure smooth and fair functioning of the DCF algorithm, there is a set of delays that amounts to a parity scheme. So let us look into those set of delays. So you have different delays that are named according to these descriptions. So you have short IFS or CIFS, which is the shortest interference space, and this is used for immediate response actions. Then you have the DIFS, which is the distributed coordination function IFS. Okay. These are the longest interference spaces, and these are used as minimum delay of asynchronous frames or meaning for access. And then you have in between these two, you have mid-range IFS. These are used by centralized control and DCF scheme when using poles. So these are the IFS. And SIFS, these are the short IFS. These are used for basically acknowledgement and then CTS and pole response. So this type of short messages. DIFS, these are used by the centralized controller in issuing poles, and then usually this takes precedence or normal contention traffic. DIFS, these are used for all or even asynchronous traffic. Okay. So this is the algorithm for the medium access control logic. Okay. So again, basic idea is that you wait for the frame to transmit. If your medium is idle, then you wait for the duration of IFS, that is the interference space. If you find it still idle, then you transmit the frame. But let's say your medium is not idle, let's say, then you wait until the current transmission ends. Okay, you increase that time by power 2. So you wait for a particular slot. If you find a medium busy, you wait for double that slot. Next time you wait for double that slot, and so on until your context window is over, and then you send the next frame. Okay. And then the super frame for your PCF is constructed based on this. So you have the computation free period, then you have the computation period for PCF, then you have this medium, and then again your PCF starts. Okay. So again, I would encourage you to go to the book by Collins and look up these portions. Okay. You find them in chapters 13 and 14 of the book. Okay. So I will quickly go through the functionalities here, but again, there is nothing much to explain here. So these are all mainly some information that are pertinent to the 802.1 standard. And for this portion of the module, I will encourage you to just self-study and go through the book and get all the info for yourself. If you don't understand anything, there we can definitely discuss this in live sessions. Okay. So point coordination function, as you saw before, it's centralized control. So far we were discussing DCF, the distribution coordination function. Now that was decentralized. This one is centralized. So the point coordinator holds devices keep the permission set, and this is based on schedule the point coordinator determines.